Do you think the night sky has always had just a single lonely moon? Travel back 4 billion years when Earth once had 2 moons. But where did the other one go? It was devoured by its own sibling in a catastrophic collision that lasted for hours. If the moon disappeared tonight, Earth would no longer be as you know it. The oceans would become chaotic. The planet's axis would begin to tilt. And life could gradually collapse over time. But that's not even the most frightening part. What's truly terrifying is this: the moon isn't just there. It has been keeping Earth stable for billions of years. When Earth had just formed, it was still a molten sphere, its surface covered in lava, with no life yet. But then, something massive came crashing in. An ancient Mars-sized planet named Theia collided directly with Earth. The impact was so powerful that it melted both planets. A huge amount of material from the crust and mantle of both Earth and Theia was blasted into space. These fragments began orbiting Earth and, under the force of gravity, quickly clumped together to form the Moon. There is a hypothesis that this collision actually created 2 moons. The first is the one we see today. The second, a smaller moon, was only about 1/3 the size, comparable to the dwarf planet Ceres, and shared an orbit with its larger sibling. After several tens of millions of years orbiting together, the gravitational forces of Earth and the Sun destabilized the smaller moon's orbit. It began drifting toward the larger moon. Instead of crashing into each other at extremely high speed and creating a massive impact crater, the two bodies collided at a relatively low speed, about 2.4 kilometers per second. As a result, the smaller moon didn't explode. It was instead smeared onto the surface of the larger moon, like a snowball thrown against a wall. This slow collision added a huge layer of material to the far side, forming the rugged mountainous terrain we observe today through satellite images. What do you think about this hypothesis? Leave your thoughts in the comments below. When it first formed, the moon was much closer to Earth, appearing many times larger than it does today and generating extremely powerful tides. Its existence was not just the result of a cosmic accident, it also played a crucial role in stabilizing the planet, helping create the conditions necessary for life to develop on Earth. Right after forming from the debris of that collision, the moon was not a cold, lifeless rock. Its entire surface was a vast magma ocean, molten rock, hundreds of kilometers deep. Millions of massive meteorites continuously slammed into the moon's surface over billions of years. Without an atmosphere to burn them up or slow them down, every impact occurred directly and violently. At the same time, the moon lacks strong geological activity like Earth. There is no wind, water, or plate tectonics to erode and erase the evidence. As a result, impact craters have been preserved almost perfectly to this day, creating a heavily scarred surface that serves as a vivid historical record of the solar system's violent past. About 100 table tennis ball-sized meteorites strike the moon every day, around 33,000 per year. Though small, each of these impacts releases energy equivalent to about 3.2 kilograms of explosives. After its formation, the moon did not remain stationary. It began a slow journey drifting away from Earth. Each year, it moves a few centimeters farther, like a lingering trace of that ancient collision. In its early days, the gravitational pull between the two bodies was so strong that it deformed both Earth's oceans and crust, creating enormous tides, hundreds of meters high, that constantly swept across the planet's surface. These violent motions helped cool the Earth, stabilize its rotational axis, and establish the day-night rhythm we are familiar with today. Over time, as the distance increased, the moon became a silent guardian. It keeps Earth's axial tilt from wobbling chaotically, helping maintain a stable climate over millions of years, one of the key conditions for life to exist and evolve. Not only that, the moon's reflected light illuminated the primitive nights, guiding early life forms in their struggle to survive. When you look at the moon, you'll notice large, dark patches stretching across its surface. Ancient people called them seas, but in reality, there isn't a single drop of water there. These seas formed after massive impacts fractured the moon's crust. From those cracks, molten magma rose from within, spreading out and filling enormous basins. Unlike Earth, the moon has no atmosphere, no water, no wind, and no strong geological activity like volcanism or plate tectonics. On Earth, these forces constantly erode and erase traces of the past, keeping the surface young and ever-changing. But on the moon, everything is almost frozen in time. Billion-year-old craters, ancient lava flows, and the fine dust covering the surface all remain largely unchanged since they formed. This makes the moon like a natural museum, preserving each violent chapter of the early solar system. By studying lunar rocks and craters, scientists can read the history of the universe, from periods of intense meteor bombardment to the formation of planets. The moon is not just a familiar object in the sky, it is a giant fossil, preserving billions of years of cosmic evolution. A day on the moon is not a brief span of hours, as we might imagine. It is an ordeal lasting 29.5 Earth days. Due to tidal locking, the moon rotates on its axis so slowly that it takes nearly 700 hours to complete a full day-night cycle. This creates an extreme reality. A blazing lunar noon can last for 15 continuous days, with temperatures reaching up to 127 degrees Celsius, hot enough to boil almost anything. Then, darkness takes over for another 15 days, plunging temperatures down to a brutal minus 173 degrees Celsius. From the very beginning, the moon was much closer to Earth, only tens of thousands of kilometers away. At that time, it appeared enormous in the sky, and its gravity caused Earth's oceans to surge violently, creating extremely powerful tides. However, a subtle process was taking place: tidal interaction. The moon's gravity pulls on Earth's oceans, creating tidal bulges. But because Earth rotates faster than the moon orbits it, these bulges are slightly offset, and this offset transfers energy back to the moon. The result? The moon gains energy and is gradually pushed farther away. Today, scientists have measured that the moon is drifting away from Earth at a rate of about 3.8 centimeters per year, roughly the speed at which fingernails grow. This process not only increases the distance between the two bodies, but also slows Earth's rotation. Billions of years ago, a day on Earth lasted only about 5 to 6 hours. Today, it is 24 hours, and still gradually getting longer, though very slowly. In the distant future, the moon will appear smaller in the sky, tides will weaken, and Earth will rotate even slower. However, this process is so gradual that humanity won't noticeably feel the change for millions of years. If you could stand on the moon's surface, you would experience some strange differences. If you weigh 60 kilograms on Earth, a scale on the moon would show only about 10 kilograms. However, your mass remains unchanged. You could jump about 6 times higher than normal. An average person could easily leap over someone's head or throw a ball much farther. If you drop an object, it will still fall due to gravity, but much slower than on Earth. Few people know that during the Cold War, there was once a bold plan to detonate a nuclear bomb on the moon. After the Soviet Union successfully launched Sputnik in 1957, the United States became concerned and wanted to demonstrate its power. As a result, they secretly developed Project A119, aiming to create a massive explosion on the moon, visible from Earth with the naked eye. The idea was simple but extremely dangerous. A rocket would carry a nuclear warhead to the moon and detonate it on the surface. The explosion would create a massive dust cloud, reflecting sunlight and becoming a display of power to the world. Initially, scientists considered using a hydrogen bomb, but due to its weight, they opted for a smaller nuclear device. Even so, the risks were enormous. If the rocket malfunctioned and fell back to Earth, it could cause a nuclear disaster. There were also other concerns: radioactive contamination of the moon, destruction of future research environments, and unpredictable consequences for both the moon and Earth. Ultimately, in 1959, the project was canceled. Fortunately, that decision helped preserve the moon as it is today, allowing humanity not only to observe it, but eventually to walk upon it. After more than half a century of silence, humans are preparing to return to the moon once again. The last human footprints were left on that cold gray surface in 1972 during the Apollo 17 mission. Since then, for over 50 years, the moon has remained silent. No footsteps, no voices, only dust and old traces. This time, the return, led by NASA's Artemis program, along with private companies like SpaceX, has a completely different vision. Instead of merely leaving footprints and symbolic flags, the goal of the 2020s is to build a sustainable human presence. Modern astronauts are no longer targeting the flat equatorial regions, but are heading straight for the South Pole, where permanently shadowed craters are hiding white gold. This valuable resource is essential for sustaining life, but can also be split into hydrogen and oxygen to produce rocket fuel on site, turning the moon into a Vishal cosmic gas station. The moon also contains a group of minerals known as creep, short for potassium, K, rare earth elements, Re, and phosphorus, P. These are critical components for manufacturing smartphones, electric vehicle batteries, LCD screens, computer chips, and advanced military equipment. Currently, Earth is gradually running out of easily accessible rare earth deposits, and mining them on the Moon, despite high transport costs, could become a strategic backup as technologies like SpaceX's Starship reduce launch costs. Because the Moon lacks geological processes that wash away or bury metals deep into the core like on Earth, platinum group metals remain relatively close to the surface. This could make them easier to extract compared to digging kilometers deep underground on Earth. In addition, there is helium-3, a potentially eternal clean energy source. This is considered the holy grail of energy. It is an isotope of helium carried by the solar wind. Earth's atmosphere blocks most helium-3, but the Moon has absorbed it over billions of years. It is an ideal fuel for nuclear fusion, capable of producing enormous energy without radioactive waste. Scientists estimate that just about 100 tons of helium-3 could power the entire world for a year, with a value of up to $5 billion per ton. The far side of the Moon is the quietest place in the solar system, free from Earth's radio interference, making it an ideal location for radio telescopes to observe the deepest parts of the universe. Some organizations are even planning to build data vaults and genetic archives, similar to the Global Seed Vault in Norway, on the Moon. As a safeguard against extinction-level events on Earth, such as asteroid impacts or nuclear war, the Moon could serve as the safest external hard drive to preserve human knowledge and genetic material. Do you think that in the future, humanity will compete for territory on the Moon the same way it once did across the continents on Earth?